Okay, I'm going to do a few examples from Chapter 3 review so you can see how it's done. Number 2 says the price of Chevy Cobalts. Sample size is 9, and we need to find the sample mean. Now looking at the data, which I'm going to put right here, we have to enter this right into list 1. So I take my calculator, and I'm going to go to Stat, Edit, and I'm going to enter in list 1 this data. 14050, 8998, 13999, 7889, 12999, 7200, 10995, 5500, and 9980. So I should have 9 pieces of data entered, and you should always go and check to make sure you've entered everything in correctly. And it looks like I did. So now what I'm going to do is stat, calculate, one variable stat, list, stat, calculate, one variable stat, and I have to get rid of this. He's going to think that I wanted that. List 1. So here's what I've got. So I'm going to write all this information down from my calculator. The sample mean is given as 10,178. So I'm going to write the sample mean as 10,178. And I could probably round it up to 10,179. Okay? And now the other thing they wanted us to find was the range. To find the range, what I'm looking at is max minus min. So I'm going to go down here. My min is 5500. I'm going to write down Q1 here so I have everything that I need. 544.5. The median, I'm going to write it here. It's 9980. Q3 is 13499. And the max is 14050. And if I go back up here on my calculator up to the sample standard deviation, I'm going to write 3074.92. That's the sample standard deviation. So to take and find my range, I'm going to go 14050 minus, this is a minus, 5500. So my range is 8550. So here's the old data. 10,179, 8550, standard deviation of 3074.92. My IQR is 13,499 minus 7544.5. 5954.5, 5954.5. So that's A and B. Now they want to know what happens if I put in the data incorrectly. What would happen? So I'm going to go back to Stat, and up here I'm going to change this to 41050, and everything else is going to stay the same. Stat, calculate, one variable stat, list 1. And now what I'm going to do is write down my mean, 13,178.9. My sample standard deviation is 10797.46. My median is 9980. And now I've got to look at the new max, and new min. The new min was 5500. Well, it's not going to change. And the Q3, the median, I already got. 134. This doesn't change either, so here's going to stay the same. And let's see, my max, 41050. So my range is going to change. And what I have for my range is 41050 minus 5500. So my new range is 35550. My IQR didn't change either. So let's look and see which was resistant to the differences. And it looks like, okay, the mean changed. This stayed the same. Range changed, standard deviation changed, and my IQR. So what's resistant is the median and the IQR. Okay, on number 4 in the chapter review, we have a number of tickets issued. And so what I did is I actually put the data previously into my list 1. So I listed in all the tickets that were speeding tickets that the students may have been issued in the past month. So some had speeding tickets and some did not. So those are entered. And they want us to make a histogram. So I'm going to go stat plot. I'm going to turn it on. It's on. I am already on the histogram. It's list 1, so that's good. And I'm going to do zoom 9. And now there is my histogram. And they're asking us, based on this histogram, how would you describe the shape? Well, it looks like it is skewed right. So for part A, I'm going to say skewed right. Now remember, when it's skewed right, that means that the mean is going to follow the tail. So in part B, it's asked, based on this shape, would you expect the mean to be more than, equal to, or less than the median? Now keep in mind, the higher values go towards the right. So if it is skewed right, that means the mean is towards the right, which means it'll be bigger than the median. Mean is bigger than the median. Now in part C, they said compute the mean and the median. So what we're going to do is go stat, calculate, one variable stat, list 1, hit enter. Now when I do that, my mean, you can see it, is going to be 0.43, and my median, if I scroll down, is going to be 0. Now they said determine the mode of the number of tickets. Well, it looks like if I look at my data, that the number that occurs the most often is 0. So in part D, the mode that occurs the most often is 0. All right, at number 5, we have 200 samples of light bulbs that has a mean life of 600 hours and a standard deviation of 53 hours. They tell us that the histogram says it's bell-shaped. So according to the empirical rule, 99.7 equates to the mean plus or minus 3 standard deviations. So we need to find out what that lies between. So I take 600 plus or minus 3 times 53, which means 99.7% of the hours will be between 451 and 759. They want us to know what's the percentage that these hours fall between. So I usually will draw my bell curve. I know that this is 600, and I know one standard deviation is 653. 653 plus 53 more gives me 706. 600 minus 53 gives me 547, minus 53 again gives me 494. 2 standard deviations plus or minus means that this is 95%.